Good afternoon, Jan.
Good. Just in time, I
Just
finished
in time.
the conversation with my customer.
Ah, excellent. And
I
how did
just
that
had,
go?
that was good, but so I just had 5 seconds to switch language, to switch between Dutch and English. Okay.
Ah, yes, yeah, yeah. When I
Uh,
was traveling back and forth to Mexico, I was trying to um, you know, trying to build up my Spanish speaking skills, and yeah, it definitely is difficult to switch languages, but especially if you barely know Spanish in my case. But yeah, that is good brain exercise
you're much better at Spanish than me. I don't speak a word of Spanish at all,
though.
and it's sad because I live 5 kilometers from the Spanish border. So
Oh yeah, yeah,
yeah,
yeah. Although
no,
I am made to understand that the dialect of Spanish that they speak in Spain is different from Mexico and is different from Cuba or Colombia. So um, so I've talked to people who have moved from Cuba to Mexico, and they're like, yeah, I was using words that people were looking at me funny. It's like, oh, okay, it's a it's a
but I
slightly
guess
different language.
in general they do understand each other. I guess.
Yeah, yeah. The general form, so your day-to-day
Mm,
words, probably all the words that I know are the same, but it's yes,
mm.
turns of phrase. I guess it would be equivalent to me going um, to London and saying that I'm going to take the elevator up to somebody's apartment instead of taking the lift to their flat.
Yeah. And the floor numbering is also different, I think.
Oh, is it? Oh, right.
I
Yeah. Okay. Yeah. In
yeah,
Mexico, definitely is. Yeah. So
uh,
the first
I,
floor
I
is the first one above ground level. Yeah.
yeah, and I think in England and at your site, I don't know where you start counting. Zero, is it the ground floor or is it one?
Here in the
Um,
States, sadly, it is one. We start
okay,
counting at one, which is wrong, of course. But
that
um,
depends. But so for the car park, it must be zero below
yeah,
ground.
yeah, there is no zero. It's kind of like
Yeah.
BCE
Mm,
in AD. It's year one BCE followed by year one AD. No year zero. So yeah, no floor zero. It's just G1 and then G2 is below that. And yeah, but yeah, when I was in Mexico, yeah, the lobby was labeled L. It wasn't labeled zero. So that could be an improvement. Go ahead and call it zero.
yeah. It's always amazing how customs change, even on a distance of a few hundred kilometers.
Yeah.
Um, people are all the same, and it's so different.
Uh huh. Yeah.
And we all feel safe in the area where we live.
Mm-hmm.
I
Yeah.
remember one time when I was living and working in Singapore, talking about one of my colleagues, which was American,
Mm.
and if we were talking about, for example, social security,
Right.
he would not feel safe in Europe. And I said, but how do you live? How do you do if you if you live over there? So
Yeah.
everybody felt safe in his own situation, um,
Yeah.
just
Whether
what you
they're
used.
objectively safer or
Yeah,
not, it's just yeah, I'm preferable here. Yeah.
yeah.
Yeah. True.
We are so used to a certain system,
Uh huh.
but okay, humans adapt very quickly. Who would ever have thought that in 2020
Uh huh.
that at once all the borders could have been closed,
Yeah. Yeah.
or after 9/11 that there would be not a single plane in the sky on the
Right.
whole between Europe and America.
Mm-hmm.
Uh, these are things you cannot imagine, and at once it changes. So
Mm-hmm. Yeah. Yeah.
yeah,
I do remember that day, and that was a strange feeling because
mm,
uh, I live east of the Dallas Fort Worth airport, and I at the time was working west of the airport, so I was driving right past it, and
mm,
I'm so used to planes taking off and leaving all over me while I'm driving, flying over my head, and so like nothing. It's like, okay, that made it real.
Uh, or very easy with COVID, that
Hmm.
nobody could go out, that it would be all confined
Hmm.
worldwide.
Yeah.
It's something that you cannot imagine. It's not possible for the economy.
Yeah.
Well, 3 weeks later, it was
Yeah.
possible.
And then we figured it
So,
out. What? Yeah, it
and we,
hurt. It was.
uh,
We're still trying to,
mm,
recover from it, but yeah,
yeah,
very adaptable.
historical modeling.
Historical modeling. Yes. Yes.
That's
I've, um, I went back. So yeah, last week I tried to demonstrate the graph protocol, and nothing worked. Um, I then went just on my own, tried to go through those steps again, and got things working just fine. So I haven't gone back and rewatched to figure out where I got off the tracks. Um, but yeah, one difference is that um, I was working in HTTP YAC versus on the stream I was in Postman, but that wouldn't have caused the particular problems we saw. In fact, one of the problems I only noticed after I got the thumbnail back. So I have somebody that's making all the thumbnails for me, um, and I point out different points in the stream for him to grab screenshots and put them behind us. And I hadn't noticed until I got the thumbnail back that the response from one of the feed calls not only had no references in it, but the bookmark was completely empty. I was like, wait a minute, that should not happen. Um, I can't explain how that happened. Um, in the case of of you having read up to that point, well, okay, I didn't pass in a bookmark, which meant start from the beginning. So maybe in that case, maybe in that case that feed didn't have any facts in it, and so it would return the blank bookmark again. Interesting. So how could it have no facts in it? Because we just created them anyway. So yeah, I'll go back and rewatch that. Um, but yeah, I do have the working demo, and I can show you the full graph protocol, because there's a little bit more to it than I was able to show just with my first example run. And then there's more exciting stuff in Janaga.net. Some new APIs to play with. So let's get started with that. Screen 2, go live, and okay. So we are going to take a look at the blog model that is in the replicator as a service. And here I'm using HTTP YAC inside of Visual Studio Code. So there's my little HTTP YAC install. So we're going to hit the read endpoint and read all of the sites that belong to I'm sorry, we're going to start from a particular site that belongs to me, as I am logged in, and the domain is michaelperry.net. And then we're going to get all of the posts that are not deleted, that are where the delete is not restored, and then we're going to get all of the titles for those posts. So, hitting that read endpoint, we get back the titles for the 3 posts: fixing the queue live, introduction to Janaga replicator, testing the deployment. So I think these are things that that we happen to do. Well, wow, was that really? Yeah, I think we actually did that one on stream, and that was with the mobile application. But yeah, that is getting on a year ago. That's
and below 2022.
Yeah, yeah, and I think these were this was the date in 2022 that that I first got the replicator, the feed endpoint working in the Janago server. So yeah, that was test data from then, but that was not through an application in that case. But yeah, I created that test data, and then I kept using that test data, and then when I stood up the replicator as a service, that was the first thing that I hit it with. So replicator as a service didn't exist in 2022, but it did here. Okay, so that's what we get if we hit the read endpoint, and the read endpoint gives us these projections, so it's current state and time, which means it's great for seeing what's happening inside of the replicator, but it's not great for actually replicating. It's not great for pulling information down so that you can merge it with your own local replica. And so for that, we go to the feeds endpoint, and so you can see this is the same as this except for the word feeds. So we're sending exactly the same specification from exactly the same starting point, and this time we get back a set of feeds. So, and this is something that I pointed out last week. There should be 7, but there's currently 5. So I think that there's I think that it's not doing the titles as related to the restored. I think is how that worked out. But then again, now that I think about it, I might be confusing myself and thinking about inverses. There should be 7 inverses, but maybe only 5 feeds. So I'll go back and look at the proof in the book and look at the code and say, oh, the code's wrong, because that's what happens. So each one of these feeds is a forward-only stream of tuples. Tuple being a set of labeled facts. So just knowing the way that the feeds are generated, I can tell you that this first one is the tuple that contains just the post. So it's just that bit. And then this second one, it first dives into the not exist clause. So that first feed will exclude the ones that have been deleted, but it won't reinsert the ones that have been restored. So just thinking about excluding the ones that have been deleted, so if somebody starts reading this after a post has been deleted, they'll never hear about the deletion, which could cause them problems in the future. And so that second feed is giving them all of the deletions. So this one here will give them the tuple post and deleted. So it tells them about the posts that have been deleted, but where it's not restored. So restore will remove it from that feed. And so this one is how you would learn about all of the posts that have been deleted and then restored. So this gives you all 3 of those, post deleted and restored, in the tuple. Because as soon as it's restored, it's no longer in that second one, and because it was deleted, it's no longer in that first one. You can't reinsert a tuple in the middle of a feed because somebody might have read past it. So those are those first 3 feeds, and then these next 2 are to do with the titles. So the first one, or I guess that the fourth one there, is all of the titles, and then that last one is title with next. And so the full tuple that you get here is post title and then post title next. So what I think is missing, and I'll double check my proof, is there should actually be another pair that's post delete restored titles and then post delete restored title next. But for what we want to talk about today, we are interested in how you then fetch all of the facts for these feeds. So now we're going to get the feed. Oops, open up over here, please. There we go. We're going to get the feed for one of those feeds. Let me make sure that we can see which one it is. There we go. So this one that starts with UPTX, so that is the one that contains the post and the titles. So that is the feed identifier that we are fetching. And this is just a get. So we have already told it what the specification is. It cached the specification, and now it's using that in order to serve the feed. And so we grab that information, and it gives us all of these fact references. So you can see we've got a blog post. We've got a blog post titles. So these titles related to that post. It's basically taken all of these tuples of post title, post title, post title, and flattened them out. So it said, oh, this title is for the same post, so I'm just going to flatten that out. But now here we start a new post, and so we've got this post with all of its various titles, and then this post with all of its various titles. That title has changed quite a lot. And then the bookmark. These are the IDs of the 3 labeled facts in descending order. So the 3 labeled facts actually include, we go back to the specification, include the site. I didn't mention that before, but the given is included in the tuple. It is not listed in among these references because I already know you know the site. That was the parameter. So no reason for me to give you back the reference. But as far as the bookmark is concerned, it's part of the tuple, and so it's listed. In fact, the site is probably, since it's the predecessor, the earliest one, 131, and then we get the post, and then we get the title. And so that bookmark, that will continue to increase as I learn about new titles, and then also as I learn about new posts. So, as a quick refresher, the reason that it's in descending order is that these tuples might not necessarily be in a strictly topological order. So site is strictly before post, and post is strictly before title because of that predecessor relationship. So I know for certain that if I just used the title, then I would get a forward-only bookmark. But sometimes the specification bounces around, and you have different directions that you could have the topological order. And so putting them in this way allows you to have something that comes along later and then opens up an entire new part of the graph. And so when that thing comes along later, it's the first section, and now you've got different bookmarks for all of the brand new tuples that you've just learned about. Like if you're assigned to a project, and then all of a sudden you get all the tasks for that project. So that's going to be your assignment. That's the most recent thing. And these are going to be all the different tasks. So those will click through. That way you'll learn about all those tasks before you learn about the very next assignment. And everything stays nice and ordered. So the final step is the client looks at all of these references, sees what they've got in their local replica, and excludes the ones that they already know about, and then asks for asks to load the facts that it doesn't know about. So I've taken all these references and made them the body of this post request. And you know what? I don't need the bookmark. I just copied and pasted it in there, but let me go ahead and get rid of the bookmark. And I'm going to start with, we'll come back to this one in a minute, but I'm going to start with application JSON. So I send that up, and now I get back all of my facts. So these facts are listed in topological order. It's a complete graph, so it also includes the things that were part of the givens. Even though the site was the given, I'm including the site and its predecessor, the user. So you've got a complete graph. And that's because load has no idea where these references came from. It's just, hey, I need to know about these references. Okay, here's all the information that you need to know about these references.
And if you change that accept, then you get the hashes changed in indexes? Is it that?
Yes, indeed. Indeed.
Okay.
So yeah, good point. If you take a look at these hashes, they are nice long strings.
Mhm.
The public key is also this nice long string, but public keys have to be. And then these predecessor relationships. So the creator is a Janaga user with this particular hash. So there's that hash, which we already saw up here. So it's the
Yeah.
same value. Or this blog post, the author was that same user, and the site was that same site. So it's using all those hashes in order to identify those predecessors, which is a lot of redundant information coming back. So if we instead used x-janaga-graph-v1, this is where I decided to put versioning. Then, boom, unauthorized. Let's see, sessions. Let's see. Oh, it is launching another browser. Maybe I've been talking for too long. Okay. Boom. All right, let's do the Apple ID thing again. Enter my password. And two-factor authentication. Yes, your Apple ID is being used, and you're already in the same building. The request is coming from inside the house. Okay, now I trust this browser. And continue. There we go. Wow, interesting. Okay, let's go back. I think the reason that it says unauthorized is... Well, this is what the application would end up doing. When it sees unauthorized, it would end up going back to the feeds. Let's get that again. Get that particular feed. And then load again. Okay, and that worked. Yeah. So the reason that sometimes does that is that all of this information about the feeds is kept just in memory, and so we don't want to keep any client-specific data persisted, because that means that as you add more clients, you're going to be adding more storage, and those clients are fickle. They might go away and never return. And so the replicator has to be able to clean things up. So it just keeps all of that feed information in memory. And the way that it's doing the authorization is that authorization is first by specification. So you write an authorization rule that says, who is allowed to run this particular specification. It canonicalizes it, so it's not too concerned about which fields you're pulling out, but this particular shape. So it says, okay, who's authorized to run this specification? Well, it's starting from the site, so let's say the site's creator is allowed to run the specification and nobody else. And so there might be a different specification, which is show me all of the published posts that haven't been redacted. And that would be for anybody. So anybody can look at published posts, but only the site's creator can see the all the posts. And furthermore, they can only they can see all the titles of all the posts. So that starts here, and those authorization rules are run, and then it caches the fact that this user is authorized for these particular feeds, and it keeps that in memory. And then when you come back through and you get from one of those feeds, it can now look that up, say, yep, they're authorized for that feed, and they don't need to look back at the specification anymore. And then when you load, it's specifically saying If you just received this fact hash from a feed, then you're authorized for it. So that is um, kept in memory as well. So all that can be flushed periodically, and so that's what happened while I was John. Is that it flushed all of that authorization, or actually distribution rules. I've been saying the wrong word. That's distribution rules. It flushed all of those distribution results and said, nope, start over. So that's why starting over fixed it. And that's going to come back in our conversation too. But yes, so now we see the Janaga graph syntax. So there's the content type, application X Janaga graph v1, and so you can see it's got all the information and the hashes of the facts are gone. Yeah. Mm-hmm. So we still have the user. We still have the public key. So the public key is still this nice long string. Mm-hmm. But then when we don't provide the user fact hash. So then when we then send the site, the creator is just 0, just whichever fact was at the beginning of this response. And there's the fields, and then posts in site, which was fact number 1. The author was user 0. Post, the title for post 3, that's that one. So 0, 1, 2, 3 is the post. And so much smaller response, and yet still has all of the information. So you can see the prior array happening here. So this prior was number 12, and that prior was number 11. Yeah, this is the resolution of a conflict. This prior was both 10 and 9. So these two were both the prior of this one. So somehow, and I think I could only do this by writing code to do it, but somehow this particular post got 2 initial titles. And so that showed as a concurrent edit, and we resolved it like that. So nice and concise, although you still see some cryptographic stuff in here. You still see the public key, you still see these things. So let's talk about those. So after we've sent the first fact, we decided, hey, I need to send a public key. Happens to be the same public key as this user has. So so I might find a way to optimize that even more. So I'm not repeating that public key, but this was a good start. So I'm just saying, hold on to this public key, give it the number 0, because it's going to come up later. And so right here, it comes up later. So this site is not just created by Janaga user 0, it's signed using this public key, which is the public key of Janaga user 0. And that is the signature. So when you receive it, you can then grab this public key and you can validate the signature because you'll be able to compute the hash of this fact. I'm not going to tell you what the hash is, but you've got all the information. You can compute the hash on your own. And then once you've computed the hash, you've got the public key, you can validate the signature, and then you can run the authorization rules on your side. And you can say, well, was this particular, was this particular public key associated with a user who was authorized to tell me about this site? And then it can say, okay, the creator is this user, their public key is equal to that public key, therefore they are authorized. So that time it is actual authorization rules that it runs. And what's really cool about that is now I can save that signature. Now think about not just replicator to client, but replicator to replicator. That's what I'm really setting this up for. When one replicator sends a bunch of facts to another replicator, the key store doesn't go with it. So we don't know the private key that belongs to this public key. We can't act on behalf of that user. But yet, I can still send all of the signatures along with you, and you can authorize them and say, yep, this fact was created by an authorized user, and then you can continue to share that information. So you can replicate this authorized information. And each replicator can run the authorization rules locally and say, yes, I will accept this. So that's the part I wasn't able to demonstrate the very first time, because at first I was just testing it locally without any kind of authorization. Can I get this thing working? But here, as it's deployed to the replicator as a service, we can actually see the signatures.
And how much space does it save on average?
I haven't computed an average. Let's see if. Unfortunately, I'm not seeing the content length, but yeah. Let's see if there's. Okay, 9,200. Oops. 9,277 characters there. Yeah, it's back to unauthorized. Bing. Bing. And bing. Okay, so double check. 9277. So if we go back to application JSON, then we get 12,284, which is a bit of a cheat because this is not formatted JSON. So if I, okay, let's see, can I, let's see if I can figure out a way to do this. What if I go to node? All right, and then I've got a this being JSON. I can put it. Well, let's see. Object is equal to that. Let's see. Copy. Yeah, sure. Paste as one line. Boom, 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 boom. This is kind of fun. Let's see if this works. Oh, syntax error. Okay, that didn't quite work. Yeah, what I was hoping to be able to do is use Node in order to convert this thing into a formatted JSON string. But, and then we would get a true answer. If I were to just squeeze out all the white space, would I get less data? Well, I can tell you for sure I'm getting less data. And that's because notice that this format doesn't include the signatures. So since I was changing the format, I also wanted to solve that problem. That's something that I'd planned on for a long time. And so it's like, hey, let's take the opportunity, let's do it. So I'm squeezing out all of these hashes and also all the JSON structure, and then instead giving you all the cryptographic information. Yep. And there are some places that we can take it from here. So yeah, so far we've been looking at the load endpoint. That's currently the only one that I've augmented to use the Janaga Graph protocol. Mm-hmm. But it's this is just a way to describe a graph. We're describing graphs all over the place in this thing, so why not use it for other endpoints? So in particular, save. The save endpoint. Well, what I can do is pull up the create post. You can see this one is the write endpoint. So here we are describing facts more or less programmatically. So this is almost like you're writing some JavaScript code, although it's not exactly JavaScript, and just building up these facts and then saying, okay, write them to the replicator. That's not the format that that the application uses. The application uses the save endpoint, and it sends a JSON fact graph. So it sends something closer to this style. So okay, here's some graphs. Save it. So that means that that save could also send one of these up to the replicator from the client, which gives us a couple of really cool advantages. So right now the save endpoint only uses the authorization header. So here I'm using OAuth2. I'm signed in as a particular user, and so it's associating that user with a Janaga user and looking in my key store to get the private key. But here I can also use this format to save facts that are signed by a particular public key. So I could tell you about a Janaga user that is not me. And then I could say, here's the public key, now here's the signature for the facts that that user is creating. And in fact, that user doesn't even have to be associated with any user in that key store. And so this is how I'm going to support the pattern where you create a user on the fly, use it to sign a few facts, and then those facts authorize your true user, and then you continue with the pattern from there. So so even the mobile application will be able to generate a public-private key pair, use that private key to create a few signatures, and then delete them from its memory. And that private key will never leave that machine. It won't survive those first few facts. It'll never make it into a key store. And yet we can still exchange these signatures. So that's going to be an improvement on the save side, in addition to resolving the size issue that we're facing.
I think it's especially for the load that we risk to have very big graphs. For save it should be more reasonable, no?
My team has actually run into this problem on both sides. So yeah, I'm still working the HTTP error 413. So that's while uploading or downloading. And what they've developed a model that where you submit an order, and that order has a lot of predecessors because it's using the transaction pattern, and so that entire graph for the order submission is repeating a whole bunch of those predecessors in order to give you a complete graph. So yeah, they are running into the fact that in Express, when you've got the JSON body parser, it's going to first limit the amount of JSON that the amount of text that it's going to parse, and then Express is going to give you back a 413 on save. It's doing the same thing on the read side, on the load side. So if I give it a JSON object and then it serializes it and the serialized version is too big, then instead of returning it to the client, it will give the client back a 413. So that's happening in both directions. So one side benefit of this is that it bypasses the express JSON body parser. And instead, when I give back this graph, I'm giving it back in an array, and then there's a little loop in here that's serializing one fact at a time, just keeping track of their hashes. So it doesn't have to create an entire JSON object, just to send back to the client all at once. So this is more memory efficient, and gets around the original problem. You still have these small JSON objects, but it's serializing each one at a time, and it's not using the body parser in order to do that. So I get to control that, and I'm not doing that check. So let that be a huge fact there, with a lot of fields, or a really big field. Let's see what the limit is. So I'm going to be using this format on save, which is an interesting. That's an interesting part of content negotiation. Content negotiation in HTTP says on the request, say what you will accept, and then the server will find the format that it supports that matches what you accept. So I could say I'm going to accept either this or application JSON, and the the server will say, go back to the beginning.
Yeah. But it starts with the first one? Or?
Not the first one, but the most, its favorite. So even if I were to say this, it would still pick the graph protocol.
The server can decide an order. Yeah.
Yep.
It says that's the most efficient coding to use.
Yes.
Okay.
Yes. So right now, this is actually exactly what the client does. It passes both of these, and then the server picks those up, and picks among them. So that works for things that the content type that you're going to download, but the content type that you're going to upload, you have to express that at the time that you're sending the request. So how do you do content negotiation on that? And there's lots of different ways that you could try to go about it. They all kind of end up in the same problem. I've already deployed a replicator as a service. Let's suppose that that I've got a replicator out there that I just don't upgrade, and then I start hitting it with clients and other peer replicators. It's going to behave the way it behaves no matter what. I can't change its behavior now. So if they talk to it, they're only going to get the behavior that's there. So if they try a content type that it doesn't know, if they try to send a X application or X Janaga graph v1, then it's going to say, "What are you talking about?" And it's going to give back an error. And so the fallback way of doing this content negotiation, this negotiation protocol is to try something, and then if you get an error, then fall back to something less, and then for the rest of that session, keep using that content type. There is another way to approach this, and that is to actually make the replicator give you back some endpoint that describes what it accepts. So so some service discovery endpoint, which I have not yet built into the replicator, but this is telling me I really need to do that. So I'm going to implement the fallback, but then I'm also going to add the service discovery endpoint. So now if I hit the service discovery endpoint and it says 404, so okay, well I know that um, you are an old replicator, and so I'm going to go back to JSON. So that will be now a good pattern to have in place so that I can start to upgrade replicators, and you don't have to worry about upgrading your replicators all at the same time, or at the very least from the inside out.
Yeah.
So that's the way that when people are deploying entire services, they will upgrade the thing at the center and then upgrade the things at the edge later. When you're doing a mobile application, you have no control over when that client gets updated. So it's a good thing it's all the way at the edge. So the accept part, at least it can do the right thing. And
also, if you put a replicator in another organization and you start replicating between organizations.
Yep. Yep. So. Which, because of this, because I'm sending signatures, that opens up that use case. So each organization is going to have its own key store. It's going to know about its own users. But they're not going to be able to sign things for the other organization. No. But they want to receive signatures so they can authorize them. So yes, yeah, I'm excited about that use case coming true at some point in the future.
Yeah. Yeah. There's nowhere a counter that an identifier of a replicator that goes above the number of replicators.
Yeah. No, this is yeah, that's the funny thing. So if you look at things like the Paxos algorithm, the algorithm starts with assume that you know the number of nodes in your network. Call it n, and then it uses n all throughout the algorithm. It's like, well, you don't know that, so that's a bad place to start. So yeah, I'm looking forward to. Hey, you can just join a network, add a new replicator, and it starts talking with the others. Yeah.
As long as the distribution rules
Yep.
allow it.
Yep, the distribution rules and the authorization rules, yes. So then there is one last place where this this protocol is going to come in handy, and that is back here on feeds. So remember, this gives you back just a yeah. So you're getting one feed. So this is feed / a particular feed. So this is giving you back a set of fact references, so that you can eliminate the ones that you already know about. The use case here is, as a client, I just saved a bunch of stuff that went up to the server, and then I immediately refresh the page or something, and then it's going to now fetch from that feed using that bookmark, and then the very next things it's going to see on the feed are the facts that I just sent. So in that case, you would see, I know all of these hashes, so therefore I don't even need to make the load call. But I need to do that so that I get the bookmark. Because prior to this, I don't know what the bookmark ended up being on the replicator. And this could also have collected some other things that were happening concurrently. And so I might see some facts that I don't know about and some that I do. And so doing it this way, the bookmark keeps marching forward, and I can filter out the ones that I already know about, and you don't replay facts back to the client. The cost of doing that, however, is that I send you this SHA-512 hash for everything, and yeah, if you look at the actual facts, ignoring the signature, the actual facts are on the order of the same size as the hash as a whole. So how much is that really saving you? But that is now costing you something else, in that I can't use any information about the feed when I do the load. Load doesn't actually know where you got these hashes from. But if instead of returning these hashes, these fact references, if I returned the graph protocol from this feed's endpoint, then I could use that information. So downside, it would replay facts back to the client, but upside, I could gain even more optimization by using the graph protocol and knowing which predecessors have already arrived on this particular feed, and which public keys have already arrived on this particular feed. So let's go back to this picture. So right here, we have so we have a complete graph. It starts at the, oops, that's interesting. There's my token. It's only good for a little while, so that's okay. So we have this graph that it starts at the very top with the predecessor. It's got the public key, and then it keeps going. If I somehow knew that you had already read through this much of the feed, and then you come back and ask for more, then I could know for certain that you've already seen this fact, and you've already seen this public key, and you've already seen this site. So, even though maybe I'm telling you about a new post in that same site, so we can see all these posts have site 1, site 1, site 1. I could just say, hey, here's a new post from site 1, and I wouldn't have to repeat this first part. So yeah, I do have to repeat now the facts that you've already sent me. Those come back to you once, but now I no longer have to repeat the predecessors at the top of the graph, which are going to come back to you every single time if you use the complete graph. And so in order to support that, this graph protocol needs to have something else that it can provide. I'm going to do that right here at the bottom, where we've got the bookmark. So we had, what was it, 214, 189, 131, something like that. So it'd say, okay, there's the bookmark, and now you call back with that bookmark, and it knows that it's already sent you these particular facts. So there's a little wrinkle in that, which means I have to do one more thing. So that wrinkle is this whole idea that I was talking about the feed information being stored just in memory, so that it can be dropped. If all of that information is stored in memory, that means this entire list of which facts occurred at which index, that is all part of that. I don't want to retain that indefinitely for all of my feeds. And so that means I do need the ability to pick up from a particular bookmark, because the bookmark is persisted, but then say, you know what, I'm starting from the top of the graph again. And so what I am currently thinking about is some some extra bit of information here that then lines up with something at the top. So I might say this is I'll just call it a this is the Merkle tree idea. This is the Merkle hash of the stream of facts that I have sent you before, and so it's starting from this place, or it's empty. Maybe empty even looks like this. So if you see nothing at the top, then you know, okay, flush the indexes that I have. It's starting over, so it's going to give me those predecessors. But then when I get down here, this is the Merkle hash that's telling me that the next time you call, I'm going to try to start from here, and then we'll still be in sync. Because your memory will be the same as my memory. So that means this, let's go back to feed. This URL here accepts a question b equals, and then you can send in the bookmark. So it accepts that. So I'm thinking that we will also have another Merkle hash equal, and you can say, I have the last time that we talked, this was the hash, and so if you still know about that hash, let's continue from that point in the conversation. If you don't, start from the beginning, it'll be fine.
Okay.
But when I say start from the beginning, I don't mean start from the beginning of the feed. We still don't want to repeat all that history. Remember that diagram in the book of the that poor mobile device receiving all the history from the transaction pipeline. Still not doing that, but we're trying when we can to save a little bit of stuff at the beginning.
It will be much more efficient that way.
Yep, I think so. And then you can tweak the knobs a little bit. You can say, okay, when I'm talking to a fellow replicator, then I know that they are interested in a few very high-level feeds. They are going to be sticking around for longer. I can go ahead and save those streams for a longer duration. And now replicator to replicator conversations are really efficient. But then when you're talking to a mobile application, it's like, yeah, let's keep it alive for a little bit, but mobile app users are going to stop using their phone after 30 seconds anyway, so yeah, we don't have to keep it indefinitely. So yeah, I'm pretty excited about that.
Yeah, that's very nice progress. So your team is waiting for this for a real release of this.
Yeah, so I am. I'm continuously releasing new versions of the Janaga.net client, and so they're testing with those. And then they're not using the replicator as a service. They are using the Docker image, and so I'm updating the Docker image whenever I make a change inside of the replicator. But I'm also pushing that to replicator as a service because I want to test it that way.
Good. That's nice.
Yeah. So more stuff happening in that area. Oh, I see a question online. Which language is this? So what we were looking at is the factual modeling language. It is specifically Janaga. And so the client, the .NET client and the JavaScript client both generate replicator, or the factual modeling language. It's also the language that I use in the book, The Art of Immutable Architecture, to prove some things about specifications, which is pretty cool stuff. So hopefully Jelly 312 is still on and can grab the answer.
That was on the text channel that a question came in?
Oh, that came in on YouTube.
Oh, okay. I'm not following YouTube for the moment. Otherwise, I will have the sound with delay.
Yeah. Yeah, like a 6-second delay. It's going to be really maddening. But yeah.
Good.
There we go.
By this week, I should catch up all the things I was too late, or at least the urgent things. And then I can start thinking again for implementing it in BWS.
Yes, excellent. So yeah, now you're going to get the benefit of all of the bugs that my team has found, and it's like, hey, this is working great.
And then having something that works more reliable, because I'm still before yesterday, a new customer that started up and then started on other Android telephones, and then you see on that model he's not syncing, because that's a big problem for Android. You take a Samsung, you take another brand, and they have settings which are slightly different. And to support software that is syncing, you discover that on some they are not syncing, and sometimes it's a problem because battery saving is wrong. Sometimes it's a problem because program rights are not given. It's a quite difficult platform in that sense.
Yeah. Well, yeah, I don't know that I will have a solution for all of the platform problems, but at least they will be shared problems. So we will get to experience them, and once we find a solution for them, it'll be baked in.
Well, little by little, there will be solutions.
Yeah.
But the problem is that in the current version, I'm using something that is a little bit of here, a little bit of there, that I combined myself. And yeah, in the beginning it worked very well, because I forced my customers to use a particular telephone, which was not a problem years ago, because a lot of them were not really using telephones yet for the work.
Right.
But now everybody has a telephone, so you cannot say, you have to buy that model.
Right. Yeah, this is the one I carry. Why do I want to have two bills?
And if it doesn't work, I cannot buy for every model one to test.
Yeah.
And testing on a customer's telephone is very difficult, because the telephone is considered much more private than a computer.
Yeah.
And for sure, if you do it remotely, it becomes even more complicated. So you need something that just works, that you download from a Play Store, and everything works without adapting settings.
Yeah, and hopefully we can get there. It's going to take, like you said, testing on all the devices. No getting around that. But by backing the Janaga project with Replicator as a service, then that can generate some income that then I can use in order to set up these test farms and to set up a process by which making sure that it's working on all devices. And then when it doesn't work on a device, I'm not looking at a particular application. I'm just looking at the library and the protocol and seeing why doesn't it work on that device.
If you have a library which is used by a lot of people, no need to test on all devices. People will come back with problems. And No, once it is solved, it's solved for everybody.
Mm-hmm.
But if you just use it for a couple of customers, and
Mm-hmm.
they come with a new phone, again, not working. So you have to work on a much larger scale.
Yeah, yeah. Well, I'm going to take the approach that it's even more important to test on all devices, but you have the capability of doing so because it's at a larger scale. So
Yeah.
yeah, yeah. I don't want application developers to get the angry phone calls and then have to figure out, oh wait, this is Janaga problem, and so call me. Um, so rather find those directly, but that's going to take some time.
I'm looking forward to the day where you will have to go through the telephones to start a recording.
Yeah.
Yeah.
Yeah, and I'll use one of those testing services, so it'll be somebody else's telephone somewhere else, and they'll just have these little foam fingers that are tapping the screens.
Yeah. Do they already? I never came across a testing service really for phones in
Yes.
in big amounts.
Yes. I can't remember some of the services, but yeah, um, you can get testing services that are all done programmatically. So you put you put all the accessibility identifiers into the screen, so that then you can write a script and it'll run that script and test just behind the screen. But then there actually is a service that I heard about where they're literally using a robot to poke a foam finger onto a phone, so that they can test actually through the screen. And then machine learning to take a look at the image. Okay, has it refreshed now? Okay, now I can hit the button. Does this match the expected value? So there you get real high fidelity testing. Is that the right term? But yeah, you're really testing what the user can see and what the user can touch.
Yeah, but do they have the possibility to test that on, for example, 10,000 different models?
Yes.
With all their different firmware versions?
Yes, that is the primary reason for these large testing centers to exist.
Well,
Yeah,
I
I
never
can't do
looked.
that.
I never looked into that for Android, but I never came across one. So.
Yep. I'll go back through my notes and see if I can pull out some names.
Okay. Michael, see you next week.
Indeed. I will see you then.
Okay. And curious for the new improvements next week.
Yes. Yeah, me too.
Okay. Have a good week.
Right,
Bye-bye.
you too. Bye.